Good morning, everybody. How are you? Today we'll talk about the other part of chapter 6, trigonometry 2, and this chapter is about non-right angle triangles. Last time we talked about the sine rule, okay? And today we'll talk about the cosine rule. Now, how do you use the cosine rule? Remember, if I would like to recap on the sine rule first, remember the sine rule? The secret of it, that you're looking for an angle opposite side. If you have two pairs of an angle and opposite side, then when information is missing, you can do it. Now, this time is different. This time, if I give you a triangle, and what's the information given to you? The information given to you, in such a case, if I give the length of that 35, and the length of this side or this edge is 25, and this is 64. So what are you noticing here? You are given the length of two sides, maybe in meters and in meters. This is 35, 25. And the angle in between, or the angle included between those two sides, is given also. What am I looking for? In that special case, I'm looking for, let's call this an A. Alright? So if you ever given two sides and an angle in between, whether the angle is obtuse, acute, maybe 90 degrees, maybe that much, maybe this much, as far as you are given any two sides and one angle, then I have to apply something called the cosine rule. Not the sine, cosine, tangent. No, that's for right angle triangle. This is for non-right angle triangle. See, this is not 90. So how do I apply the rule? How can I use it? Some people like to put the rule. I like to use it later on. I would say, as if you are applying Pythagoras, a squared equal this squared plus 35 squared. As if it's what? Right angle triangle. But is it a right angle triangle? No. Therefore I put minus, and because it's not right angle triangle, I have to put something here. What is it? I multiply those two times 2 times the angle in between, which is 64. Look at it carefully. I will square the first side as if you are doing Pythagoras. Think of that like hypotenuse, even though it's not a hypotenuse, but it's opposite that angle. If this was 90, for sure that's called hypotenuse. 25 squared, 35 squared, minus 2 times 25 times 35. So the 2 is always there. There is no need to derive the rule for you, because we need, as an engineer, we need to use it. Times the angle between them, but it's cosine. Maybe some people will say, but Sarian, if you just give me a rule, well, fine. I can call this angle A. If I call this one B, small b, then the opposite angle for it is called B. And if I call this little c, or the length of that is called C, then the angle facing that, or the vertex, is called big C. And the rule simply, A squared equals B squared plus C squared minus 2 times B times C times cosine, the angle between B and C. B and C. It's called A. So, if you love those rules, you can use them. But I doubt it's a waste of time for me. So guys, what is the answer for all of that? Go to your calculator, and then you'll find out if A squared is 1083, take the square root of that, and the length of the side A is 32.9 meters. Remember, you've got to put the bracket here on the calculator. Remember, when you press cosine, the calculator will by default open a bracket. But when that's done, you must close the bracket for the angle, but because I open the side here, you've got to close it again here. So you have to press twice. This angle could be 100, Could be 180, 160, 170, 30, 40, 50. Could be an angle between 0 and 180. All right? Let's call this example 1. Very straightforward. Now, let me give you example 2. What's example 2 all about? Let me assume, okay, I'm giving you 3 sides. You are known. The 3 sides are known. All right? This is 6.5 centimeters. This is 7.5 centimeters. And the third side is just 9 centimeters. And guess what's the question? I want the size of the largest angle. You have theta, alpha, beta. Which of these angles it could be the largest? Why could be? It must be the largest. Which one? It's the one that facing the biggest side. This is the largest side. So by default, this angle is the largest. Or the question can simply say, find the size of the angle theta. Sometimes we say find the measure. Measure means yes, the size, how much is big. So, can I use the cosine rule? Oh yeah. Focus on the angle. Where is the angle given or known? Theta. This one. In the question before, it was given. In this question, I want it. But which 2 sides are enclosing that angle? That's the question. Which 2 sides? Is it the 7 or the 6 or the 9? Those sides. These 2 sides are enclosing this angle. So that must be called what? The opposite one. So let's apply the rule. A squared, which is 9 squared, equals B squared plus 7.5 squared minus, I told you open a bracket, 2 times 6.5 times 7.5 times cosine the angle in between. You can call it A or you can call it theta if you wish, but we wrote theta, we stay with it. So what's your game? To put everything on one side. I can put those 2 over here, like that. 9 squared minus 6.5 squared minus 7.5 squared equals. And then you multiply those. I can use a calculator to find their answer. What is 2 times 6.5 times 7.5? Oops. It's a minus 97.5 cosine theta. What is that altogether? 81 minus 6.5 squared minus 7.5 squared equals, oops, it's a minus 17.5 equals minus 97 cosine theta. You divide both sides by what? By minus 97.5. Why? I want to get rid of that. So I divide it by itself. All right, they cancel out. So go to your calculator and guess what? The minus will go. So cosine theta equals 17.5 over 97.5, which is going to be 7 over 39. And therefore, the answer of that is, how do we deal with it? It's the inverse cosine of the 7 over 39. Go to your calculator, press the calculator, it will be roughly 79.7 degrees. That's the size of the angle theta. So when do you notice in this rule? I use the cosine rule. I have 2 situations to use it. Remember them. Either you are given 2 sides and angle in between, or you are given actually 3 sides. And any angle can be found. Just stick to the rule. apply the rule properly. This side is the one facing the angle where this angle is between those two sides. So that can be called B, and that is called C, and that's your A. Whether this is given or not given, you still have to put it on the right hand side. You have no other option to try to make new ideas. No, very fixed. This guy who's facing that angle, where this angle is between two sides, whether you find it or whether it's given to you, must be put on the left hand side. On the right hand side, we'll put that square plus that square minus twice times 2. Don't tell me why 2. Don't tell me, can I put 3 please? You said 2. Can I put 2? Because my mom said 3 is better. Don't do these things, please. Just the 2 times this times cosine the angle in between. Unfortunately, the angle in between the one you like. So use algebra. Square this, multiply those. Take this one or take those over there to make it positive. It doesn't matter. My advice to you, if you really want to practice what I've just said, if you wish, which is important before your quiz or your assignment next week, I propose for you, do 2 simple questions. Okay, problem B, problems, and you have example 1 and part C plus D on page or pages 5 and 6. If you do them, we discuss them in the class if you support, but I know you're not gonna ask, but why not? It's your right to ask. Now, let's give the last option, an example from real life. Why do we teach these things? I know there are many reasons for that, but let's give an example. And this example is in your lecture notes. All right? So this example is all about what? What I'm looking for. I'm looking at example 4. I think it's in page 12. Don't forget, chapter 2. No, 1, 2, 3, I'm sorry. It's number 3. I know it for sure. It's called example 3, yeah. You're having what? A tower. That's how it's drawn. Some sea here, some water in there, and there's a prisoner who wants to leave the prison, and there is a guy here who's called a sniper, has a gun, protecting his jail. This guy left the jail until he went and ran until this point. All right? So this guy tried to shoot him with an angle of depression. So we have here something called angle of depression, and this angle of depression is 50. All right? Good. He couldn't get him. So I can call this point A. Or he moved away from that B. Sometimes I say he moved closer, nearer. It doesn't matter. He moved until this point B. Then this guy, shoot him again here with another angle of depression, and its size is 40 degrees. Is it 40? Yeah. No, it's not 40. It's 30. Okay, gentlemen? Since this is 50, that is 50. Since this is 30, like a Z, that's 30 because they're called allied. So what's the question? If the distance between those 2 points, all right, was 45 meters, how can I find the height of this guy or the height of the wall of the building of that tower? Now, let's go right away for that. If it was to me, This is, don't forget, this is also 90 degrees. So I can generate 2 or 3 triangles. One of them is small like that. I can generate this triangle. I can generate that triangle. You notice those two are 90 degrees. Now I need to know which one to start. So it's better if you're smart is to label you. This is the height. The same in here. This is 30. And also this is 30. But that's 50. This is 45. This is 45 plus something. And that is something. Why I'm calling something? I may don't need to find it. I can call it X. If you're happy, I'm going to call it X for you, X for you. All right? I can make it worse if I think about it, maybe. So, ladies and gentlemen, and since this side and this side, they touch here, I can give it a name W. So you know there's something here. They are common. So if I find this, I know that. And if I know this, I know that. But do you think I can find this from here? I have H, I have X, and I have W. 3 unknowns. Forget about it. No good. This is very, very, very mean. How about we look at this one? But don't forget, there's something you need to finish up. If this angle is 50, that angle is 130. They are called supplementary, they lie on a straight line. If this is 130 and 30, 60, therefore this is 20, or 50 minus 30, 20. And guess what? I have here 130, I have here 20, I have a side and an angle, and I have a side and an angle. Then I should be using what? The sine rule that we taught last time. What does sine rule says? What does it say? Sine the angle opposite to 45. What is that angle? 20. Equals sine the angle of 30. That is opposite to W. If you cross multiply, then you should get an answer which is about 65.8. So, gentlemen, ladies, this is 65.8 and this is 65.8. So if you look at here, this is 65.8. This is not 65.8. This is not W. And by the way, that one is this one. It's useless. So this triangle, it's useless. It doesn't help me. Actually, this is W. I know some of you said, no, I let you go, because nobody can reply. So, if I know this, I know that. With this, I can find H. What relates H to X? Tangent 50, which is opposite over 65.8. If you cross multiply, then look how you cross multiply like that. Then H will be 50.4 meters. So I drew the 3 triangles so I can give you something to see. But what did you notice? Some of you could not see. Is this the same? No. Why? This is that, but that one is this one. Look, I'm looking at the big triangle. If I call this B, if I call this C, this is called B from here to here. Why this is called B, C. But this is A, C. So there's no point I find BC. No point I know that. Now you get this out of the way. Okay? Now you can see. If I find this, who's common between both, I can take this and put it here. And the door is open. That's how we use sometimes the sine rule, sometimes the cosine rule. Now my advice to you, that was example 3. you can add to this page example 2, which is, I think, on page 7. Have a nice day. Try to work in this. Don't waste your time. Have a nice weekend.